Welcome back, everybody. Now we are going to solve a system using the elimination method. And the idea behind the elimination method is exactly what it sounds like. We're looking to eliminate something. And the something, or the what are we eliminating? That's one of the variables. So I'm going to look to add or subtract these two equations so that one of the variables is eliminated. If I were to add them right now, we would get 6x plus negative 9x, which is negative 3x. Negative 4y plus 6y would be positive 2y. And adding those constants at the end would give us a 0. Now, what we've done is we've formed an equivalent system, right? This equation right here, negative 3x plus 2y, it actually runs through this equation and this equation at that common solution point. But we don't know what that point is. So we can't really proceed yet because we need either the x's to completely go away or the y's to completely go away. So I'm going to rewrite the system over here on the left, but this time I'm going to multiply it, or one of the equations, or both, by some kind of number that will force that elimination to happen, like we were talking about. So as I look at this one, there's a couple ideas that come to mind. I first look at the 6 and the 9, and I think, okay, what number can I multiply this 6 by, and a different number I can multiply negative 9 by to make it so those two numbers are the same, besides the fact that one is positive and one is negative. So I'm thinking of the number 18, because I can multiply 6 times 3 to get 18, and I can multiply negative 9 times 2 to get negative 18. So that would be one way that we could start this elimination problem. We can multiply this top one by 3 and the bottom by 2. So what I'm doing here is I'm forming equivalent equations, and I'll multiply that number into every single part of the equation. 3 times 6, 18x. 3 times negative 4, negative 12y. The 5 times 3 is 15. Don't forget the constant. People love to forget the constant because they're working towards eliminating one of the variables, but then they forget, oh, well, I need to multiply 5 times 3 as well. So now I've got this equation is the same as this equation. It's just been magnified by 3. And then the bottom equation is going to be 2 times negative 9, give me negative 18x. 2 times 6 is going to give us plus 12y. And 2 times negative 10 is going to give us 2 times negative 5 is negative 10. There we go. Okay, so before I add these, I want to show you another way that we could have formed an equivalent system. And this time we'll focus in on the y variables. So you got to think, what number do 4 and 6 have in common? So it can't be 4, that'd be too small. Can't be 8, because 6 does not have a common factor with 8. Well, they do, it's 2, but not big enough. 12. Right? 12 would work here because I can get that to say negative 12y. I can get this to say positive 12y. So let's try again, but this time I'm going to write the system, and the top one is going to have a multiplier of 3. That's going to make negative 12y. And then over here, negative 9x plus 6y equals negative 5. Let's multiply that by 2. And then that way, I'm getting that to say 12. But wait a minute, isn't that the same set of numbers? 3 and 2, 3 and 2. It is. That's not always going to happen. But for this example, it actually works out. So either variable that you set out to eliminate is going to actually lead us to the same thing in this example. Because something wicked this way comes. If you add these x's together, you're going to get 0. You add negative 12 and positive 12, that's going to give you 0. And then we get equal to 5. So when does 0 equal 5? The answer is never. 0 never equals 5. So this is actually going to lead you to, it's no solution. When you have 0 equal to another number at the end of one of your elimination problems, the answer is no solution. Now, think about that. How is it that two lines could never cross? They're parallel. And if we want to examine why they're parallel, let's just take a look at each of these equations. If I solve this one for y, I'm going to try and find the slope. I get 4y over here. Let's take 5 away. I get 6x minus 5 equals 4y. And then I'll divide by 4. We get y equals 6/4 x minus 5/4. And that means that the slope is 6/4 or 3/2. So that is the slope of our first line. And seeing that we got no solution, we're going to verify all this by finding the slope of our second equation. So I'll look at negative 9x plus 6y equals negative 5. And I'm just going to try and verify that the slope is indeed 3/2. So I'll add 9x to both sides, trying to get y all by itself. And then divide by 6. Y equals 9/6 x minus 5/6. And if we look at that slope, 9 over 6, that is really just 3 over 2. So since both of these have the same slope, that's another reason that we can say no solution here. Okay, so if you use elimination, you're going to get to 0 equals a number. If you examine the slopes, you'll see that they are the same. Sorry, there they are, 3/2. And that's how to do elimination. Okay, so I will see you for another video very soon, and I hope you have a great day.